Hello kids, today we are here for maths concept skills, chapter 1 rational numbers from your forward channel. So, can you tell me what are fractions? Give examples of fractions, please. Okay, 3 upon 5, 4 upon 7. And what are about integers? -1, 2. 0 is an integer or not? Very good. 0 is an integer. Okay. So, moving forward on the chapter, rational numbers. What are rational numbers? Rational numbers are the numbers which are presented in the form of P upon Q, where P and Q are always an integer and Q can never be equal to 0. So, what I am saying? Okay. Rational numbers are the numbers that can be expressed in the form of P upon Q, where Q is never 0. Today we are here to tell you something about the properties of the rational numbers. So, the properties of the rational numbers, as we have seen, first property is closure property of rational number. Closure property of a rational number. So, what is the closure property of a rational number and what are the operations on which these properties are used? 4 operations we are using: addition, subtraction, multiplication and division. For the first property, we are taking the addition of a closure property of rational numbers, whether it holds good for rational numbers or not. First property of addition of closure property of addition of rational numbers states that if we add any two rational numbers, the answer is always a rational number. Here is an example: 5 upon 12, 2 upon 7 are two rational numbers we are adding, and the answer is 59 upon 84. Is it a rational number? 59 upon 84? 59 is an integer. What? 84? Again a positive integer? Yes. Is it not equal to 0? No. It's 84, so it is a rational number. So, first properties of a rational number states that it holds good for addition property, closure property of addition. Closure property of addition holds good for rational numbers. Now, moving on to next. Before that, if the 3 is also an integer, this is what a closure property states. Next property is subtraction. Whether it holds good for rational numbers or not. Closure property again for subtraction states that if we subtract any two rational numbers, answer is always a rational number. Always a rational number. So here we are taking example 4 upon 5, 2 upon 5. These are the two rational numbers we are subtracting, and the answer is 2 upon 5, and it states that a minus b is always a rational number. So rational numbers are said to be closed under subtraction also. Rational numbers are said to be closed under subtraction also. This is what closure property of rational number states for subtraction. Any query till now? Okay, you are getting the point here that closure properties hold good for subtraction and addition of a rational numbers. Moving on to next property, that is the multiplication property of closure property of multiplication of rational numbers. Next property is again multiplication. Multiplication. Can you tell me if we add or multiply, if we multiply any two rational numbers, what will be the answer? Suppose 1 upon 2 multiplied by 1 upon 2, do it. 1 upon 2 multiplied by 1 upon 2. What is the answer? Any one of you? Yes. 1 upon 4. Very good. So, is it a rational number? Yes. Yes. Okay. So, you are saying it is a rational number. Why it is a rational number? Because 1 is a integer, positive integer, 4 is again a positive integer. So 4 is denominator and it's not equal to 0. So 1 upon 4 is a rational number. So can we say that multiplication property is also holds good for closure property of multiplication holds good for rational numbers? Can we say multiplication property also holds good for rational numbers? Here we are taking another example 1 upon 7, 2 upon 3. The answer is 2 upon 21. It is also a rational number, so closure property holds good for multiplication of rational numbers also. Next, this is A into B is also a rational number closed under multiplication. Next property is division. If we divide any two rational numbers, suppose here we are taking an example 4 upon 5 and 0. 0 is a rational number or not? Yes. 0 can be represented as 0.1. Again, a good answer. That means you are clear about this is P, this is Q, and Q is not 0. So 0 upon 1 or 0 is always a rational number. Here we are taking 4 upon 5 and 0 upon 1. When we are dividing, it is not defined because denominator becomes 0. If any time the denominator of a rational number becomes 0, it is not defined. Again, it will not be 1 upon 0. It's not a rational number. So answer is not defined. So is it holding good for division? No. But very good. So division is not closed. Rational number numbers are not closed under division. Rational numbers are not closed under division. Here is an example. This is an exercise for you. We are taking two rational numbers 2 upon 3, 5 upon 2. Let me do first one for you 2 upon 3 plus minus of 5 upon 9. I am adding, answer is already given to you. 2 upon 3 minus 5 upon 9 will be equal to, LCM will be 9. This is 1 upon 9. So it is a rational number. Hence, we have seen answer is yes. You can do all the similar questions. Taking another example 2.5, 0, 0 and 1. These are the three examples you have to do and complete this paper. Any query about the closure property? Can we move forward? We are moving forward. Next property we are going to do for the rational numbers is commutative property. Again, the operations are addition, subtraction, multiplication and division. Commutative properties, for commutative properties we have to take two rational numbers. Let me take, here we are taking one rational number as 5 upon 8 and second is 1 upon 2. Suppose my A is 5 upon 8, my A is 5 upon 8 and my B is 1 upon 2. For commutative property of addition of rational numbers, we have to take 5 upon 8 and for the second case 5 upon 8 plus 1 upon 12. For the second case we have to take first part, that's 1 upon 12 as first one and the second one will be 5 upon 8. So we have to find whether A plus B is equal to B upon B plus A. Again I am telling you the commutative property states if A plus B is equal to B upon A, we have to check it. Here we are taking two examples again, as I have told you. These are the two examples we are taking, and you can see this is 17 upon 24. This is 17 upon 24. If we are adding A plus B, this is my A, this is B. A plus B is equal to 5 upon 8 plus 1 upon 12. 17 upon 24. For the second case, I am taking B plus A, that is 46. 17 upon 24. This is 17 upon 24. So these two are similar. So we can say commutative property holds good for addition of rational numbers. Commutative property holds good for addition of rational numbers. Or we can say A plus B is always equal to B plus A. Next, we are taking the subtraction of two rational numbers. We are taking A as 4 upon 5 and B as 2 upon 3. These are the two rational numbers we are taking. On subtracting these two rational numbers, the answer is 2 upon 15. Answer is 2 upon 15. A minus B is 2 upon 15. Let me check for the B minus A. B minus A is B. B is now 2 upon 3 and A is 4 upon 5. So I am getting answer as minus 2 upon 15. So what you have seen? A minus B is not equal to B minus A. A minus B is not equal to B minus A. So it's not holding good for subtraction. Commutative property of rational numbers not holding good for or true for rational numbers, subtraction of rational numbers. Next property is, again I have told you we have to check the four operations: addition, subtraction, multiplication and division of rational numbers for each and every property. Now again I have to take two examples. My A is minus 2 upon 3 and B is 5 upon 7. A is minus 2 upon 3 and B is 5 upon 7. The answer is minus 10 upon 21. For the second case, I am taking B into A. B into A means 5 upon 7 into minus 2 upon 3. That is again equal to minus 10 upon 21. So, multiplication property holds good for commutative property. So, rational numbers are said to be commutative under multiplication. Rational numbers are said to be commutative under multiplication, or you can say A minus B is always equal to B into A. Multiplication A into B is equal to B into A. Next property I am taking division. Again for each and every case we are taking examples. We have to define it whether it is true or not for each and every example. Again, for A and B are two rational numbers I am taking here. A is minus 4 upon 3 divided by 5 upon 6. The answer is 4 upon minus 4 upon 5. Minus 4 upon 5. For the second case, I am taking this as B into A. B divided by A. B divided by A. B divided by A. So, on that also, B divided by A. Let me check. The answer is minus 5 upon 2. These two are again not equal. What about the closure property? Is it holding true for division? We are regarding the two rational numbers. It is holding good for division of rational numbers. Closure property I am asking. It's not holding true. Good. Very good. Now, again here we have seen A divided by B is not equal to B divided by A. So, numbers are not commutative under division, or you can say A by B is not equal to B by A. Here is again one table, and you are taking here, the first one is this, second one is this, A plus which is 1 upon 6 plus or minus 1 upon 5. This is equal to LCM will be 30. Here 5 minus 6. That's 6 minus 1 upon 30, which is a rational number. So we have to write yes or no accordingly. For the second case, again we have taken second one. This is our second example and this is the third example. For all these questions you have to do yourself and we will discuss. Okay kids? Now, next, this is our, from the table we can observe that. I have taken one example of addition. Sum for rational numbers, the sum of four rational numbers is always same. For these, this one and this one, we will verify after completing the table. Now, third property, first one is closure property. Second, we have taken commutative property. Third one, we are taking associative. These are all the properties we are taking for rational numbers. Associative property, we have to take three examples of rational numbers and verify whether it is good input for addition operation, subtraction operation or subtraction. Then after that, multiplication, and last one will be fourth operation we are taking as division operation. All the operations will be checked for associative property of rational numbers. Are you getting my point? Any query till now? You are clear about closure property. Then second one was commutative property. Third one will be associative property. For the associative property, here we are taking three rational numbers. As I told you, take three rational numbers. Let me take as A, 2 upon 7, B as minus 3 upon 2, and third one C as 7 upon 5. Again, we are taking three examples of rational numbers. First is 2 upon 7, second one is minus 4 upon 3, third one is 7 upon 5. So these are the three rational numbers I am taking for checking whether it is holding good for closure. Associative property is holding good for addition of rational numbers. Good. Addition of rational numbers. Here I have taken A into B into we were talking about addition. Associative property, we are taking three examples. 3 upon 8, 7 upon 8, minus 5 upon 8. 3 upon 8, 7 upon 8, 5 upon minus 5 upon 8. So these are this is the example. This is the example. 3 upon 8, 7 upon 8, 5 upon 8. These are the three rational numbers we are checking. First, we are taking A plus B plus C. For the second case, we are taking A plus B together, and C will be out of the bracket. So first case we are taking these two and within the brackets. For the second case we are taking these two rational numbers in the bracket. 3 upon 8 plus, first of all, at the bottom states we have to take calculation of bracket. So we are subtracting these two rational numbers. within the brackets as the one of the rational number is negative and 3 upon 8 3 upon 8 then is added with 2 upon 8, answer is 5 upon 8. For the second case, 3 upon 8 plus 7 upon 8 are added because all both the rational numbers are positive rational numbers. So it is 3 plus 7 upon 8 minus 5 upon 8. That is again 5 upon 8. So associative property is holding true for addition of rational numbers. That means a plus b plus c is always equal to a plus b plus a plus b. B plus C is within the bracket for first case and for the second case A plus B are within the brackets. Now, moving on to subtraction property of the rational numbers. Subtraction properties of the rational numbers, or again we have to take 3 examples. First is 3 upon 24. This is my A here. My B is 7 upon 8. And my C is here I am taking 5 upon 5. Okay kids? Now, what we have to do, again we have to take 2 rational numbers within the brackets and 1 rational number, then calculate it after calculating the bracket. At the bottom stage, we have to solve the bracket first of all. 3 upon 24 minus, because we are subtracting here. So, A minus of B minus C is equal to A minus B minus C. We have to check this. Okay? Now, 3 upon 24 minus 25 minus 10 upon 24 because these two rational numbers are subtracted within the brackets first of all. Then we have to subtract the answer from 3 upon 24 and we are getting minus 8 upon 24. What we are getting? Minus 8 upon 24. Can you solve it in your notebooks also? You will be more clear about the question. Good. It doesn't take more time. In first case, I am taking A out of the bracket and 7 upon 8 and 5 upon 12 are taking within that bracket. Okay. You are getting the same answer? Now, for the second case, I am putting A minus B minus C. This is my A, this is my B, and this is my C. Answer is minus 28 upon 24. These two are not equal. These two are not equal. That means A minus B, B minus C is not equal to A minus B minus C. We have verified for this case. So, commutative, after commutative, is the commutative property holding true for rational numbers? Okay. That means you are clear about the concepts. Now, here it is not holding true for associative property. Associative property is not holding true for rational numbers. Subtraction of rational numbers. This is what does not hold true for subtraction of rational numbers. Associativity does not hold true for subtraction of rational numbers. Can we move to next property? We have taken subtraction property and addition property of rational numbers. For what? Associative. Associative property of addition of rational numbers. Associative property of subtraction of rational numbers. Now we are moving for associative property for multiplication of rational numbers. Again, as we have taken 3 examples, we have to take 3 examples of rational numbers. In this case also, my first number is 2 upon 7, second one is minus 3 upon 2, third one is 7 upon 5. This is my A, this one is B, and this one is my C. For first case, minus 3 upon 2 and 7 upon 5 are within the bracket. That means 2 upon 7 into minus 3 upon 2 into 7 upon 5. Answer is minus 3 upon 5. Answer is minus 3 upon 5. For the case 2, we are taking 2 upon 7. That means first case we have taken A into B into C. B and C are within the bracket. For the second case, A and B are within the brackets. 2 upon 7 minus 3 upon 2, 7 upon 5. Answer again minus 3 upon 5. So A into first case, A is out the bracket, B into C. And for the second case, A into B into C is R equal. Closure property solving would prove for multiplication. Associative property, commutative property is also holding true for multiplication of rational numbers, and again associative property is holding true for multiplication of rational numbers. So we can say A into B is equal to A into B into C is equal to A into B into C for three rational numbers. Moving on to next property. This is division property of rational numbers. Associative. Whether it is holding true for rational numbers or not, we have to check. Holding true, again we are taking this as A, this as B, and this one as C. For the first case, again B into C are within the bracket. For the second case, A and B are, for A is also of the bracket and B and C are within the bracket. For the second case, A and B are within the brackets and C is outside the bracket. So we have to divide 2 upon 5 divided by, again what we have to do? We have to solve the bracket first of all. Minus 3 upon 2 divided by 6 upon 5. This is equal to 2 upon 5 divided by, I am taking this first of all, minus 3 upon 2 as the bottom state. We have to take the terms, we have to solve the terms within the bracket first of all. So it is minus 1 to 2 upon 5 divided by minus 5 upon 4. Again, we have to take reciprocal 2 upon 5 into 4 upon minus 5. And the answer is minus 8. This is minus 9 I am taking here. Or you can, afterwards, you can take it in the standard form. Answer is minus 8 upon 20. What is the standard form of rational numbers? Why I am telling you about standard? Okay. The standard form, you are saying the numbers don't have a common factor. Another, anything more about standard form? Standard form of a rational number states that negative number is double the denominator. If we are getting, suppose we are getting any number suppose we are here for minus 4 upon minus 7. It is not a standard form because denominator is negative. For making a rational number to be in the standard form, this rational number to be in the standard form, we have to get it multiplied both denominator and numerator by minus 1. So we will get a standard form of this ratio. That is minus 4 upon 7. Minus 4 upon 7. Denominator for a standard form, number should never be a negative. Again, this is minus, I was telling you about the division of three rational numbers. We have to check A into B divided by B But in bracket, within the bracket, B divided by C, where the answer is minus 8 upon 25. For the case 2, A divided by B divided by C. This is a situation, and the answer is here minus 2 upon 9. Answer is minus 2 upon 9. These two are not again equal. These two numbers are not equal, so we can say rational numbers are not associating under division, or associativity does not hold true for division of rational numbers. Associativity does not hold true for division of rational numbers. Rational numbers are not associated under division. Again, a table that is a homework part for you. We have taken 3 rational numbers and we have to check all the situations: addition, subtraction, So, have you seen division is or not true or for associativity of rational numbers? That means rational numbers are not associative for division, operation of a rational numbers. Associative terms hold true for division of rational numbers. Again, understanding about the table, you have to complete this table as a homework. Now, here are the examples. 3 upon 7 added with minus 6 upon 11, minus 8 upon 21, 5 upon 22, and we are getting a rational number here. For another example, we are taking 4 rational numbers and multiplying them, because as we have seen, it is holding true for multiplication. This is a closure property. Okay, you are telling me we have to take 2 examples. Here we are taking 4 rational numbers. We are getting a rational numbers. But what we are doing actually, which operation we are performing? We are multiplying. So, answer is a rational number. We are not taking example A to B equal B to A. So, it is a closure property of rational numbers or multiplication. Now, again moving to the next, some more properties of rational numbers. This is the property of 0. It states that if we add a rational number and 0, the rational number itself is the answer. The sum of any rational number and 0 is a rational number itself. Here we are taking example 2 upon 5 and we are adding it to 0. Answer is what is a rational number. You can see, you can add these 2 rational numbers. Answer is 2 upon 5. So we are getting this rational number only. For the second case, I am getting 0 plus 2 upon 5. And the LCM is again 5, 0 plus 2. This is always a rational number itself. This rational number only. So we have done a plus 0 is equal to 0 plus a, and that is a only. This is what the property of 0 of rational number gives, and this property is known as additive property of 0, and 0 is called additive identity of rational numbers. 0 is called additive identity of rational numbers. Moving on to next property. Next property is property of 1. This is property of 1. Again, we are taking a negative number, negative rational number, and 1. We are multiplying it, and we are getting minus 5 upon 12. For the case 2, we are multiplying 1 with a positive rational number. Here again, we are getting the rational number itself. So, this property is known as multiplicative property of 1, and the multiplicative identity is 1. Multiplicative identity is 1. Additive identity is 0. Multiplicative identity is 1 for rational numbers. So we have done notional properties, commutative property, associative property, property of 0, property of 1, and one very important property of rational numbers, distributive property of multiplication over addition and subtraction. This is distributive property of multiplication over addition and subtraction. Here we are taking 3 rational numbers. This is A, this is B, and this is C. So first of all, I have told you, we have to solve the bracket first of all, as per the rule of formula. We are solving the bracket first of all, and the answer is minus 20 upon 90. That is multiplied by 2 upon 7. This is for the second case, here what we have done, A into B plus C. For the second case, we are doing A into B, and this is positive sign, which we have to take care of. A into B, A into C. A into C. A into B plus C. Then I am telling this A into B, A into C. This positive sign comes in between A into B plus A into C. Here for first case, we have done this one. For the case 2, we are doing that it is 2 or not. 2 upon 7 into 5 upon 9 plus 4 upon 7 into 3 upon 10. And this gives the answer. Same answer, minus 23 upon 3 by 5. Minus 23 upon 3 by 5. Minus 20 upon 3 by 5, I was telling you. And this is what we have done, distributive property of multiplication over addition. Distributive property of multiplication over addition, because we are multiplying and adding the rational numbers. We are multiplying and adding. We are multiplying and adding. So it is multiplication over addition. Let us check this one also. But we are doing for, whether we are doing for subtraction, yes, we are doing for the subtraction. This is a rational number. This is my A, this is my B, this is my C. 3 upon 8, A into B minus C as per the rule says, let me verify, A into B is minus of A into C. This 95 comes in between and this is A into C. Whether it is true or not, let me check for it. So, here my A is 3 upon A, in bracket I am taking B and C, I am subtracting these two rational numbers. Now, LHS says 3 upon 8, this is formula, as per formula, solve with the bracket first of all, this is 3 upon 8 into 2 upon 15. I am getting 1 upon 20. Let me verify once again. 3 upon 8, 2 upon 3, 8 upon 15. After solving the bracket, 10 minus 8 upon 15 is 2 upon 15. 3 upon 8 multiplied 2 upon 15 is 3 upon 8. This is 3 upon 8, 2 upon 3, 8 upon 15. After solving the bracket and getting answer 2 upon 15, I am multiplying 3 upon 8 by 2 upon 15. I am getting answer 1 upon 20. For RHS, I am performing this equation. This is my RHS, this is my LHS. So, 3 upon 8 multiplied by 2 upon 3 minus 3 upon 8 into 8 upon 15. Here also I am getting 1 upon 20. So, these two are equal. So, we can add verification that distributive property of multiplication over subtraction is also holding true. Over subtraction is also true, over subtraction and over addition is also true. As we have seen, A into B plus C is equal to A into B plus A into C. For subtraction, A into B is always equal. A into B minus C is always equal to A into B minus A into C. So, for any two rational numbers, then three rational numbers, sorry, A into B plus C, A into B plus A into C, A into B minus C is equal to A into B minus C. Again, a very easy task for you. A, B, C, we have taken three examples of rational numbers. We have to verify this property, this property, this and this. We have to solve these property rules. Sorry. This we have to solve. And we have to write the answer here only. All of you have to. Now, let me recall once again what is the additive identity of rational numbers. Can anyone tell me? Additive identity. Additive identity was okay, 0, very good. And what about multiplicative identity of rational numbers? It's 1. Okay. So, what is the answer? Minus 11 upon 13 plus 0 is rational number. That is minus 11 upon 13. For this is 17 upon 35. There are some more questions for you. This is we have to be by using distributive property of rational numbers. We have to solve these questions and verify whether this is true or not. For these three rational numbers, again, 4 parts are given to you. Competency based question, which of the following is shown here. This is multiplication, this is multiplication here. You can judge it. You have to complete it. 1, 2, 3, 4. MCQ question. Rational numbers are closed under multiplication, subtraction, addition, all of the above. All of the above is the answer. Which statement is true for division of rational numbers? These 4 parts. Additive identity is. Additive identity is 0. 0. All the remaining parts is your task, home task. Again, some of the subjective questions are for homework. Lab activities also there. We will do it. So I think there is happy learning, fun with maths. You must have enjoyed the properties related to rational numbers. We will meet once again for any query. If you have any query, we can meet you. Okay. Thank you all.